Hello, welcome to Algebra 1, Lesson 2.7. It lines up with Algebra 1, Module 2, page 7. So if you are following along online in the book, that is where we are. So here we have different ways to write linear equations. Now remember, we're in the process of talking about linear functions. But we can write it as an equation. And remember, an equation is when two expressions are equal to each other. So with an equation, you're going to have a y written in it, whereas with a function, you're going to have this fx or g of x or m of n, something like that, in place of the y. Okay, so slope-intercept form is our most common form of a linear equation. We use it to quickly identify the slope and the y value of the y-intercept. We also have the point slope form. This is the second most common. The general form here, and it's going to be used to find the zeros of the equation. The standard form, again, you're going to be able to write it as a function if you use f of x instead of y. There's the identity function where f of x equals x, or that is when y equals x, and that's going to look like a diagonal line. It's going to go at a diagonal there. Y of n is a constant function when n is any real number. Now this one is going to look, oh, my straight lines are a little lacking here, but it's going to look like a horizontal straight line. Okay, it's going to go on forever and ever in each directions, but it's horizontal, and this one will always have a slope of 0. And just a side note here, this one always has a slope of 1. And then you have the vertical line, x equals n, where n is any real number. And this is a vertical line. There is no way for this one to be a function, because if you did the vertical line test where you took your vertical line, your pencil, and you took it across the graph, would it touch more than one point on that line at any time? Well, yes, it touches no points until it gets that line, and then it touches all of them at the same time. So it doesn't qualify as a function, but it is a linear equation. So with this one, this vertical line, we talked about some of these we can already identify the slopes. In this one, the slope is 1. In this one, the slope is 0. In this one, the slope is undefined. Okay, so those are some 3 special ones that you should automatically know when you see them written out. All right, so here we're going to start with the slope-intercept form, and it's called slope-intercept because you're able to easily identify the slope, which, remember, when we were talking about slope, we introduced it, we said it's always identified by the m. That's because of this equation right here. M is the slope, and then the b is the y value of the y-intercept. That's how it gets its name, slope-intercept form. Now, m and b are always going to be filled in with some type of integer when you have the linear equation written out. Y and x stay as variables. Y and x will show up in your equation, but m will have a number and b will have a number. Okay, and when you write the y-intercept, you need to remember that it is a point on the coordinate plane, so it's going to be written as an ordered pair. And if you're looking for a y-intercept, the x value is always 0, and then the y value is whatever b is. And since this is a plus sign right here, you're going to take whatever sign the b value is. If it's a minus here, it's going to be a negative thing. If it's a plus here, it's going to be a positive b. All right, and so then we also use this to easily find slope or y-intercept. When it's written in this format, you can also build the equation if you have the slope and the y-intercept using that information. We'll get into that in the next lesson. All right, so here we have y equals mx plus b. We have an example of it down here. What is the slope and what is the y-intercept? Well, this is easy enough for us to identify. We see the coefficient of the variable is going to be m. And so 2 is our slope, m equals 2. But wait, Miss Andrea, I thought the slope was always a fraction, a rise over run. So I see a rise of 2. What's the run? Remember, you can always take any whole number and place it over 1 to make it a fraction. So we have a rise of 2 and a run of 1 when you have just a whole number. So m equals 2. Well, what's our y-intercept? Our y-intercept is an ordered pair, and since we're looking for the y-intercept, my x value gets a 0. Now, what goes here in the y spot is whatever I have for b. b is a positive 3, so I'm just going to put 3 right there. So here you have some equations to go ahead and practice on your own. I want you to pause it, complete the equations, the answers, find the answers, and then come back. All right, welcome back. So here's our first one. And as you can see, it's a little out of order. Our order is y equals mx plus b, but it's not going to deter us because we can still find the answer. We know that m right here is the coefficient to the x. So it's not the first number that's going to be my slope. It's whatever the coefficient of x is going to be my slope. So m equals 3. What about the y-intercept? Okay, well, it's not going to be just the last number. What it is the constant. So what is the constant? The constant is -1. So I'm going to have here my y-intercept is 0, -1. All right, so moving on to number 2 here. M is my coefficient of the variable. M is -9, so my slope is -9. The y-intercept, remember 0 is going to go first, and then I have a positive 5 for the b is going to go in the second, the y spot of the y-intercept. Now, for whatever reason, 3 doesn't continue there. It goes up here, so we're just going to go ahead and jump up here as well. Y equals 5. Now, if you remember this is a horizontal line. We just covered that when we went over the different ways to write equations. So if you remember that this is a horizontal line, you can remember what the slope is. Automatically, you know that the slope m equals 0 because it just is always that on a horizontal line. But let's give you some details as to why that is for people who like to understand how we get the answers. So remember, our form for slope-intercept is y equals mx plus b. In this case, we have the b of positive 5, but what would the m be? Well, I don't see an x in this equation, so that must mean that it's written in a way that is not going to change this equation. So what could go into my m spot that would make my x disappear? Well, if I had 0 as the coefficient of x, that would make it disappear. 0 times x is simply 0, and 0 plus b is going to be b. So whatever 5, that's why whenever you see a constant by itself, the coefficient of the variable is 0. So it doesn't necessarily mean that there's not a variable or a coefficient that goes with the variable. It just means that whatever that coefficient is made it do a disappearing act, right? All right, so that's the slope. Well, what's the y-intercept? The y-intercept is going to always have a 0 in front of it, and then our constant is 5, so that's going to go in the spot of the y. All right, so moving on to number 4, our slope is 2/7. That was easy. That's the coefficient of the variable. And our y-intercept is 0, comma. You see it's a negative, so we're going to put in -1. Okay. Then let's look over here at y equals x. Now this is the one that is a diagonal. And if you remember, what is our slope in this one? Always. Our slope is going to be 1. And that's easy enough because we have an implied coefficient right here of 1, an implied number 1. So that should be easy for you to remember. Now, what is going to be our y-intercept? The y-intercept is a little trickier in this one because I don't see a letter B. I don't see a constant. Well, let's think about it for a minute. What can we add to this that would not change it or possibly even disappear? Well, a constant I could add to this that wouldn't change it is going to be 0. So my constant is 0, or my B is 0. So my y-intercept is the point of origin, 0, 0. Okay. Now x equals 3. Remember, what is our slope in this one? It's undefined. Okay. And in this case, it is a vertical line, x equals 3. It's also not going to cross the y-axis. 1, 2, 3. It's never going to cross this y-axis here. So there is no y-intercept for any vertical line unless it's x equals 0. And then it's every single possible answer. Okay. So here's some answers written neatly for you. And I also have some extra information here. Y equals 5. It had a special name of a constant function. Here, this one had a special name of an identity function. That goes back to the first page that we looked at where it listed out all the linear equations. You should already have that written in your notes, but it always is good to write it again. Here, there is no slope and no intercept. The slope is undefined, and this one is not a function. Even though it's a linear equation, it's not a function, whereas everything else on this page is. All right, so here we have a linear equation in slope-intercept form. So we need to graph it. We're going to use the information that we have to graph this point. And so the first thing we're going to graph is we need a point. We got to start with a point. Well, there's a point hidden in this information because of the y-intercept. Remember, what is our y-intercept? It's an ordered pair. It's a point. And so our ordered pair for this is going to be the x of 0 and the y of 3, right? Let's see, I've got that typed up, I'm pretty sure. There we go. And so let's graph that point. Here we go. And x value, we're not going to the right or left any, and we're going up 3. So that's a point of 3. Then our slope right here is 2. And remember, we need that as a fraction in order to do rise over run. So we're going to go up 2 and to the right 1 because they're both positive. So I'm going up 2 in green and to the right 1 in blue. I'm going to create my new point, which is the point 1, 5, right? So let me get rid of those arrows there. And now all you have to do is connect the dots. It goes back to your kindergarten class when you were playing connect the dots. And you're going to draw the line. Now on the computer, we don't have arrows. When I draw with the computer, it doesn't have arrows at the end. If you're drawing it on your piece of paper, you want to include the arrows at the end of this line, because remember, a line goes on forever and ever in each direction and never ends. The only thing that actually ends is a line segment. It has points at either end. So when we draw lines, remember to write your arrows. All right, so let's move on to point slope form. Now, this one is very helpful as well, because sometimes you're given 2 points instead of a point and a y-intercept. And that's where this one's going to come into play for us. We're going to use it to graph an equation. We're going to use it to build the equation from information we're given. And we're going to use it to find some information. So let's look at it with graphing. Let's graph this. Y plus 1 minus 2 times x minus 5. The first thing you need to do is to identify a point. Remember, anytime you're graphing, you want to first start with a point. So we have to identify a point here. And when we look at this, we have a point that's hidden inside of it, right? Because we have this negative y1 and negative x1. Okay, this means these are filled, as you can see, with numbers here. So this is what we're going to use to build our point. Our point is we're going to use the opposite. Remember, negative means opposite. So if you have a number 5, if you want to find the opposite of that, it's negative 5, right? So when we have negatives of something, that means the opposite of something, okay? So since our formula has a negative, what we're going to plug in is the opposite of what we see in our actual equation. So -5 here means I need to plug in the opposite, +5 for my x coordinate. And then a +1 means I need to plug in a -1 for my y coordinate. And this is the hidden point in the point slope equation, okay? And then you notice that we also have a number here for in the M slot, and then the X and the Y stay as variables. So I have this written out neatly for us. And this is that information about how you need to find the negative of the x1 and the y1 values to find the point. And our first point is 5, -1. So let's plot that here. We went over 5 and down 1. That's the point, 5, -1. Now we need to identify the slope. Remember, m is our slope. That's the same no matter which way we write the equation. If you ever see m in a formula, it means slope. So our slope here is -2. Well, that means that we're going to have a fall or go down 2 and a run or go right 1. So let's look at this. In green, we went down 2, and then in blue, we're going to go to the right 1. And that gives us our second point. Now, when you draw a line, you only need 2 points. Parabolas, we're going to get to later. You need 3 points to more accurately draw those, minimum 3 points. And for a line, it's only 2 points. So we're going to go ahead and just draw on the line here. And remember, if you're writing it on paper, draw the arrows. All right, so the last thing I want to go over here that I did not include in my PowerPoint is I want to, let me pull up my whiteboard. What if you have an equation that's not written out in either of these forms, right? And how do you get that to be into, again, the most common form, the point slope form? So here we have, and I'm going to make this so I can see it a little bit better, make it bigger. Say we have x plus y equals 2. Well, we want to get that in slope-intercept form. Y equals mx plus b. Well, this is going to go back into those, I think they were called real equations, when you have more than one variable and you have to solve for one of the variables. So in this case, we want to solve for y, because as you can see in our formula, our goal, y is by itself. So we just have to undo everything that's being done to y. One of the things when you have addition and subtraction, you can just kind of move their sides. And if you switch sides, you have to switch signs. So I'm going to switch the side of this x over to this right side here. This right now is a positive x. My y is positive. It's going to stay positive because it's not moving. As my x switches sides, it's going to switch signs. So it's going to become a negative x. And then my 2 is there. It didn't move sides, so it's still a positive 2. And so now I have it in y equals mx plus b format, and my m happens to be -1. That 1 is implied right there. Okay, I've got another one for us, and I'm going to want you to pause the video and work this out on your own and then come back. All right, welcome back. Remember, we're trying to get to y equals mx plus b format. So we want to solve for y, or we want to get y by itself. So the first thing that I'm going to do is I'm going to take this 3x term here, and I'm going to switch sides. I'm going to move it over to the right side. So in order to do that, I'm going to start with the information that I already have. I have 8y here, and it's a positive, so it's going to stay positive. And I have equals. I'm going to put my -24 over here because I like the proper format is to have the variable first. So I'm going to put it first here. Actually, let's say what happens if we don't have it first. Let's do it that way, negative 24. And then I've got my 3x. Well, if it's changing sides, I need to change its sign. So 8y equals negative 24 minus 3x. The way most people are used to doing it, the common way is, well, I need to subtract it from both sides. Minus 3x, minus 3x. Okay, now I need to cancel it. Okay, so you see we're still getting the same thing. 8y equals negative 24 minus 3x. So as long as you think if I change sides, I change signs. So anything that crosses the equal sign, you're going to have to change the sign. And that works with addition and subtraction. Of course, multiplication is different. And we're going to get into that now because what's happening to the y? Well, it's being multiplied by 8, right? So how are we going to have to undo that? Well, we have to divide by 8. So that cancels out. But what you do to one side, you have to do to the other side. But which thing should I divide by 8 by? Well, technically, you're supposed to divide the whole thing by 8, right? Well, that's hard to work with. So is there an easier way to write that? There is. What you can do is every single term gets divided by 8. So now we have this is reduced down to just y. And then you have negative 24 divided by 8. I always start with my signs. I have an odd number of signs, so my answer is going to be negative. 24 divided by 8 is going to be 3. And then I have negative 3/8x. Well, 3 can't be divided by 8, and there's no way for me to reduce that. So it's already in its reduced form. So negative 3/8, and then you just can move x to the side when it's on the top as a numerator. You can just put it to the side. It's different if it's in the denominator. We would have to treat that differently, and we'll cover that at a different time. But if it's in the numerator, you can just move it to the side and create a fraction for the slope. Now, is this in y equals mx plus b format? The answer is no, because our variable is last and it's supposed to be our constant last. So all we have to do is rearrange these terms in a way that fits what we have. So we need our variable term to be first, and we need our constant term to be second. And remember, you need to keep the signs that they have as you move them around, because they're not going to cross the equal sign. They're not going to change sides. You're just rearranging them within the same side. So they're going to keep their signs exactly as they are written. So let's start with the variable. We have negative 3/8x. Then we're going to have our constant minus 3. And this is in y equals mx plus b format. All right, so I've got another one I want us to put in y equals mx plus b format. X minus 3y equals 6. Okay, so x minus 3y equals 6. Let's get this in y equals mx plus b format. Go ahead and pause the video, take a minute, get it done, and then come back and let's check it. All right, so the first thing I want to do is I want to get this x to that side, okay? So I'm going to have negative 3y equals, I'm going to put 6 off to the side, and then my x is changing sides, so it has to change signs. So it's minus x. Well, what goes right here in between the 6 and the x? I didn't have anything in front of it here. Well, that means it's a positive. If there's no sign in front of it, it's a positive. So the positive sign turns into a plus sign. All right, so now what are we going to do? We're going to go ahead and do exactly what we did before and divide by negative 3. And we're going to do that for all of the terms. So we're left with y equals. Now here I've got 2 negative signs. Anytime I have an even number of negative signs, my answer will be positive. So I don't need to write a sign here. But then I've got an x which I'm supposed to be able to put to the side because it's in the numerator, but then there's no number on the top and it's just 3. Well, remember, what's the coefficient? The implied coefficient right here for this x is number 1. So this is 1/3 x, okay? Plus, oh, well, look at this. I have an odd number of negatives. I only have 1 negative, so it's not a plus. It's going to end up being a minus, right? And then 6 divided by 3 is 2. So y equals mx plus b. This is my final answer. I got it in the right format. All right, we'll see you back for the next lesson momentarily.